Okay, good morning students. Today in chemistry we have started the chapter number 4, chemical kinetics. In that we have discussed about the classification of the reaction according to its speeds. Today we discuss about the rate and rate constant. Okay, rate expression, how to express the rate, that we discuss. That is known as specific reaction rate. And then we discuss the rate constant. Okay, rate constant K. Chemical kinetics mostly deal with the rate of the reaction. So rate of a chemical reaction is expressed at constant temperature and pressure on concentration of reactant. The rate of the reaction mostly depends upon the concentration of the reactant. Reactant concentration, if it is more, then reaction will be very fast. We take one equation, that is A plus B is converted to C plus D. Here A and B is the reactant and C and D is the product. Suppose I am writing the stoichiometric coefficient A, means A mole of A. After balancing the reaction, A mole of A react with B mole of B to give C mole of product C and D mole of product D. Then rate is directly proportional to concentration of reactant. Here concentration of reactant is A and B and is raised to the power, that is A and B. This A and B is known as the order of reaction. In this chapter, second main important is the order of reaction. Okay, zero order and first order, its integrated rate equation and T of we have to discuss. So remember, order of the reaction, this A and B is not the stoichiometric coefficient. Order of the reaction means it is the dependency. This reaction is depend upon reactant A, but what is the order? Zero order. What is not dependent, that is zero. So this is nothing but it is the order of the reaction, and this is determined practically by the reaction, by making one of the reactant constant and changing the next. So this is nothing but order of reaction. This is not the stoichiometric coefficient. Remember this. So rate depending upon concentration of the reactant, that is A and B, raised to stoichiometric coefficient is not, but it is order of reaction. Remember this. Rate, if you write one constant, that is equilibrium constant, then this directly proportional will remove and we write A raised to A and B raised to. So now we can write what will be the rate of reaction. So rate, we can write change in the concentration of reactant. So minus dR by dt, differential rate equation, change in the concentration of reaction. Here you can write like this. Take the derivative, so that will give the instantaneous rate of reaction. Okay, instantaneous. Previously we have discussed. Minus dR by dt is equal to K into A raised to A. Here minus sign suggests that there is always decrease in the rate of rate. Okay, rate means concentration of reactant during reaction is always decreases. So concentration goes less and less during reaction. That's why we are writing minus dR by dt. This equation is nothing but it is the rate expression. So remember, this is rate expression. Rate is nothing but it is this. Second thing, you can write this in terms of product also. So plus dt by dt. Instead of reactant, you can write product also is equal to K into concentration of product. Product here it is instead of A and B, now product is C and D. So here you have to write C and here you have to write D. Raised to its proper order, that is C and D. So this is nothing but it is rate expression or specific rate constant. So two way you can write: minus dr by dt means decrease in the concentration of the reactant per time, and increase in the concentration of product per time. That is known as differential rate equation, where K is nothing but it is rate constant. K is nothing but rate constant. How you can find this rate constant? That we find. Suppose we take concentration of product or reactant. Here reactant is there and here product is there. You take it 1 mole fixed, then all value will comes 1. Then this rate is equal to dp. K is equal, this all is equal to 1. So it is nothing but K is nothing, rate constant is nothing but if you take the concentration of reactant or product unity, the rate whatever comes, that is equal to what? Rate constant K. Now we discuss about the few characteristics of rate constant. Okay, characteristics of rate constant one by one. Okay, rate constant. Okay, minus dr by dt is equal to K, A raised to A and B raised to B. Again, A and B are order of reaction. A plus B gives total order of reaction. It may be 0 order, it may be first order or second order or onwards. This K is nothing but rate constant. Again, I revise the definition. It is defined as the rate of chemical reaction when concentration of each reactant, means A and B, is unity. Means A and B, if you take 1 molar, then whatever rate will come is nothing but the rate constant K. So it is also known as specific rate constant and symbol is K. Characteristics of this rate constant. What idea you will get from this rate constant K, or what information you will get from rate constant? It tells about the rate of the reaction. How slow or how fast the reaction take place. Reaction take place in microsecond, reaction take place in 1 hour, or reaction take place in 1 year. That can be found with the help of value of K. If K value is high, rate is fast. If K value is less, then rate is slow, or reaction rate is very, very slow. Second, temperature change. If temperature change, then rate constant also change. K value also change. K directly proportional to T. Means temperature change, then rate constant will change. Third, the value does not depend upon the initial concentration of the reactant. This K value does not depend upon the initial concentration of the reactant. Means A and B. If concentration you change it initially, then whatever product is coming, but K value does not change. This K value does not change on concentration, initial concentration of it. If you take 1 molar, 3 molar, then also K value will not change. For a particular reaction, K is constant for a fixed temperature. The unit of rate constant depending upon the order of reaction. Here you can see the power is there. So if order of the reaction is changed, then this K value will change. So K value is depending upon the order of reaction. Means it is 0 order, it is first order or second order. In the next lecture we discussed about the order of reaction, means 0 order and first order, how to find, and differential rate equation related with 0 order and first order. That thing is very, very important in this chemical kinetics. Okay. So next time we discussed about 0 order and its differential rate equation and first order. Okay. Thank you.